another function, but this time I'm going to call it override underscore get underscore DB. And this is going to return this session local instance. But I'm going to rename this just so I don't get it confused. And I'll call this testing session local. And then I'll reference this. All right. And so that means right now in our current application, we're referencing the one that we created in our database.py file. But the one in our test, we're going to actually make use of this new one right here if we call this override getDB. So how exactly do we override the database or any dependency, really? Well, FastAPI has a section on here. And I think if I search for dependency, testing dependencies with overrides. All right. To actually set up the override, you just do app.dependency override, and then you provide what you want to override it with. And there's actually a better example. If I go to testing database, this will actually show you how to do that. So we've got the override DB, where we've created a different session object. And to override it, we just do app.dependency overrides. We pass in, we specify the dependency we want to override, which is anything with getDB, and then we want to override it with override underscore getDB. So essentially all that's really doing is in the functions, any of our routes, right, you can see we've got this depends getDB. So when we run that command right here, this override, all it's going to do is it's going to swap this out with the function that we have right here under test users called override getDB, which is just going to give a different session object. And this session object can point to another Postgres database. That's all we're doing. It's really that simple. That's why we set up that dependency when we first started configuring our database, so that we can easily test this during testing, because we can just use the override functionality that's used within a FastAPI. So I'm going to copy this. And right here, I'm going to paste it down here. And I realize I misspelled override, but we do have to import getDB now. So let's import that. So I'll say from app.database, import get underscore DB. And so it's going to swap the dependencies out. And since we're still referencing the app object, we're going to pass that into test client. And so now anytime we use this client, it's going to use the new database. Now, currently our database is using the environment variables, which once again is going to point to our development database. So there's a couple of things we can do. Since this is testing, we 100% could just hard code our URL, because I mean, it's our testing database. Who cares if our password and our information is already out there? So we could technically do an F string. Actually, we don't even need an F string. I could just say PostgreSQL. Whoops, this should be a string. PostgreSQL : // then we have the username. Right now for my database, it's just Postgres. And then we have the password, which is password123. Remember, this would technically be for your testing database, so it's not technically a problem if you put this in there and hard code it. However, you'll see that we could just use the environment variables and make a small tweak, but I'm just going to quickly write this out for you guys if you wanted to see it. And then the host name is going to be localhost, port is going to be 5432, and then our database name. So we could call this, my development database is called FastAPI. I could call my testing database maybe FastAPI underscore test. So whatever my project name is and then underscore test, you can call it whatever you want. And so I could just hard code that and then comment this out, something like that. Or I could use this same thing, but just do a underscore test here. And so that way I don't have to hard code anything. It's going to actually pull it from the environment variables. So whichever method works for you, ultimately, that's all that matters. Now, I technically already have a FastAPI test database. So I'm going to actually delete this for now. So we'll say delete drop. All right. So I'm now in however your Postgres instance is set up. But since we're going to be using a database called FastAPI underscore test, we actually have to create one. So I'll say create database, and I'll say FastAPI underscore test. Okay, so we've got our test database created. And we've set up the override. Let's now actually test this out. So we're going to do one last thing, and I realize since we have a brand new database, there's no tables, right? If I go down to schemas, tables, right? There's nothing there. So we actually have to build out our tables before we actually do anything. So easiest way to do that is just copy, where's my main file? Here we go, this command right here. So this will tell SQL Alchemy to build all the tables based off of the models. We could use Alembic as well. So I'll show you guys how we can kind of get Alembic set up in our testing database so that it actually performs the migrations before test. But for now, we're going to keep things simple and we're going to use this. And so I'll just paste it right there. And we can remove this models. I don't know why that's there. And you can see that we get a warning right here. So we don't have anything based. So we actually have to import that from our database file. So I'll say from app.database, import base. And I realize we actually don't need this line right here. So we'll remove that. All right. So now our test database is completely set up. And when we actually run our first test, it's going to run this right here, which should create all of our tables for us. So let's take a look at our test create user. Everything should be good. We shouldn't have to touch anything. And our URL should point to fastapi_test. So let's try this out. And I'm just going to refresh this. And yep, we shouldn't have any tables. Good, perfect. And let's run this now. So let's run just the test users. All right, and both of them passed. So how can we verify both of them passed? Well, let's go to our tables. I'm going to refresh this. We can now see we've got all three tables, right? And that's because we ran this specific, well, not that command, this command right here. And if I do a users and then, where is it? View edit all data, all rows, right? We can see that our user was successfully created. So we have now gotten our test database set up so that we no longer interfere with our development database. And keep in mind, right, your test database doesn't even have to run on your local machine. You can run it anywhere. You can run it in a Docker container. You can run it on a remote machine. You pass in the details of your test database, and then your testing environment will handle the rest. So now that we've got our test database and we've successfully ran our tests, if we run our test one more time, take a look at what happens. We get an error, right? And we get an error because we saw this before in our development database. We already have a user, so we get this duplicate key violates unique constraint because this user already exists. So when we run this again, we try to create a new user with the same exact email. And this obviously causes things to break. And so how do we get around this limitation, right? I want to be able to run my tests as many times as possible, and I want it to kind of start out with a clean slate. Well, we can make use of fixtures. So let's take a look at our fixture. And if you already forgot what a fixture was, it's just a function that runs before your test runs. I'm going to create a fixture, and I'm going to have to, do we already import PyTest? We did not import PyTest, so let me import that in here. We'll say import PyTest. And I'm going to say, I'm going to create my fixture. Call this whatever you want. I'm going to call this client. So this is actually going to return, our client, right? This is our client object right here, which is the test client, which is what we use to actually generate the request. So I'm going to call this def client. And what this is going to do is I'm going to remove this line right here and just copy this. And I'm going to say return this. And we can just remove this line at that point. So this is going to return our test client instance. And so now, to get this to actually work, I'm going to pass in our client. And so now this client object references the client that we get from this fixture. And we'll do the same thing here. So what exactly has this solved? Right now, it hasn't really done anything for us, right? Our code is going to work exactly the same. If I save things and run it again, right, same exact issue. And obviously I can go in and I can delete this and then run this, right? It's going to work just fine. But it is nice because we now have this function that runs before each one of these tests that gives us our testing client. And what's even better is I can actually change this a little bit. because I can change this to be a yield. Right? When you change it to yield, what it does is it gives us a little bit more flexibility, because now we can, run our code before we return our test client. And after the yield, we can then run our code. Actually, this should be run our code before we run our test. And then this is going to run our code after our test finishes. So now we can put in logic for, what should we run before our code runs or before our test runs. We then yield, which is the same thing as return. It's going to return our test client. And then we can run some code after the test finishes. So what we can do is, before our code runs, I can copy this line right here. So before our code runs, I can create my tables. And then after my code runs, I can drop my tables. And if you want to drop a table, you just run base.metadata.dropAll instead of createAll, and it's going to drop these tables. And so now every single time my tests run, I'm essentially going to be starting out with a clean slate. It's going to drop all of our tables, all the data in each table. It's going to return the test client. We're going to run the test. And then, I messed that up. So when we finish a test, we're going to drop all of our tables, delete our data. Then the next time the test runs, what's going to happen is we're going to create all the tables again because there's no tables. We're then going to run the test. And then just like we did before, we're going to then drop all of our tables again. So what I'm going to do is, first of all, I'm going to manually drop these. And I'm going to have to drop votes first, or then it's going to throw some foreign key errors. And then we'll drop posts and then users. Okay, so now everything should work. And I'm actually going to test this out. So once again, just to reiterate, we're going to create our tables because we don't have any. We're going to then run our test, right? Yield just returns our test client to our create user, and then we can, perform all of this logic. After that's done, we'll then drop the tables again, so we start from scratch the next time around. So let's try this out. All right, everything's worked. And if I actually go back to here and hit refresh tables, you can see there's no tables because we dropped the tables after we're done. And if I run this again, it works. We can run this as many times as we want. We don't have to worry about duplicate users because we're clearing out our database. And there's one more thing that you can do as well. If you wanted to, we could actually take this drop all and move it up here. So what's the benefit of doing like this, or why would you want to do it like this? Well, the nice part about this is, right, it's going to clear out anything we had previously. It's going to create our tables, and then it's going to run our test. And then the next test that we run, we're once again going to clear out our table. We're going to clear it out, and then we're going to build our new tables again. So this way, if your test fails, you can, pass in the -x flag to stop after it fails. And what's going to happen is it's going to keep all your tables and all of the data so you can see what was the current state of your database when the test failed, so that you can, ideally have a little bit of better idea of what's happening, troubleshoot a little bit more because you have access to your tables. Whereas if this is down here, right, it's just going to delete the tables after you're done and you can't even see it. So it's a matter of personal preference, but I like to keep the tables after it's done so that, if I do want to stop it and just kind of poke around and take a look, then I can. And if you guys don't want to use SQL Alchemy, you can do the same thing with Alembic, right? I can import, alembic.config. Actually, I think technically the import is from alembic.config import config. Sorry, not that. Nope. It's from alembic import command. So what we could theoretically do is in here, instead of using these, we could say something like, I think it's command.upgrade. So you can upgrade, and then you can go upgrade to, I think, head, right? So this will build out all the tables for you. And then after you're done, you could then go in and say command.downgrade to base or something, right? You'd have to make sure you set up Alembic with all of the right environment variables and things like that. But that's all you would have to do if you didn't want to use SQL Alchemy's built-in functionality. So I'm going to just delete that just to keep things simple. We're going to let SQL Alchemy build the tables for us moving forward, just because it's a little bit quicker than having to build all of your revisions and things like that. So one of the cool things with fixtures is that we can actually configure a fixture to be dependent on another fixture. So we can essentially pass one fixture into an argument of another fixture. And the reason why I want to do this is I want to have one fixture that returns my database object. So if I want to ever manipulate data directly, and I want another fixture that returns my client. So this one is returning our client, so I want that. But I also want another one that returns just our database object. So what I'm going to do is I'm actually going to create a new fixture. I'll say pytest.fixture. And we can call this whatever you want. You can call it, like DB or session. I'm just going to call it session. And I'm actually going to move the logic of deleting and creating our tables up to here, because this is kind of handling all of the logic for the database. And you see all of this override functionality. What I'm actually going to do is I'm going to just copy this section right here. And paste it into here. All right, so this session fixture is going to yield the database object. So the database object that we used to query things. And what I can do now is I can pass in session, this session fixture, into my client fixture. And so by doing it like this, what's going to happen is any time I go to one of my tests and I pass in the client fixture essentially as a dependency, it's going to call this one. And the client fixture will actually call the session fixture before it runs. So it's intelligent to understand that a requirement for the client fixture is the session fixture. So we're going to run all this code. It's going to return the DB object, which is going to be passed into client as the session. And then here we can perform all the logic that we normally would. And I'm going to once again copy this override DB right here. And we can remove this. And we can remove that. Nope, actually, sorry, I didn't mean to remove that. Just space these out a little bit. So it's part of the override getDB function. And here, instead of yielding DB, since there's no DB, we're going to yield session, which is the DB. So we'll say session. And then session.close. And I'm going to copy this line right here. Do the override right here, and then we return a brand new test client. Okay, and the benefit of this is that not only do we get access to the client, if we wanted to, we can also get access to the database as well. So I could say session, and then I can go in here and I can make queries like session.query, models.post blah, right? So now I have access to the database object as well, and so I can make queries and I have access to the client. But if I call just the client, remember, the session database is an input argument into the client fixture. So the session will always run first, and then client will run because we're calling it right here. And then we just move the override getDB function into here, as well as the override right here. And then as usual, we return the test client. So let's make sure we didn't break anything. Let's test out our code. And something's happening with my terminal, so let me open a new one. So let's try this again. I'm just going to do pytest test / and then test _ users. Nope, not test calculations, users. All right, and 2 passed, so perfect. Looks like we didn't break anything, and we've got a much nicer way of setting up our code. We can actually remove this override that's not within a fixture. We no longer need that, and we no longer need the create all right here outside of any of the fixtures, because we're doing it all within the fixtures now. And once again, I just want to make sure I didn't break anything, so let's test that out. And we can see 2 have passed. Perfect. All right, so right now our test users file is a little bit cluttered with all of this database information, and I would like to move all of our database specific code to another file. So under our test folder, I'm going to create a new file, and we can just call this database.py. And I'm going to essentially move all of my database code to that file. And that includes the fixtures as well. So these 2 fixtures, all of this, actually everything. We don't need any of this in our test users file. And we can just paste it into here. Now, this is going to break things because obviously it has no idea what schema. Okay, well, actually, before we do that, we do need to have schemas in here. So let me find where schemas is, and we'll just cut that out. But the other issue is that we no longer have access to the client fixture. So we have to import that. So I'll do from current directory, database, import. What is it, client? I think it's client. Yep. So now we have client. And remember, we don't need to import. Actually, we may need to import session. Let's just double check to see if this causes any issues. So let me save everything. And let's test this out. Let's see if this works. Looks like we got 2 errors. Yep. And if you take a look at the errors, it says the session fixture is not found. So we actually have to import the session fixture from this file. Even though we don't actually call session in here, because client is dependent on session, because client is ultimately calling session, we need to make sure that session is also imported. So we have to do session here as well. And so now I think this should fix our issue. So now if we run this, yep, both tests have successfully passed. And if you actually take a look at our test file, you can see our test file is a lot cleaner. It's really just got our 2 tests and a couple of imports. And before we move on any further, there's one thing I want to point out, and I ran into this issue when I was, doing a dry run through my code. If you actually take a look at your routers, and we'll go to, since we're taking a look at test create user, this is going to be the /users. So we go to users and then create user, right? You can see that the prefix is /users. So the route you want to go to is /users, and then you can see that we have to append whatever's here. So here it's appending /. Now, the way that PyTest works is that, or actually the way that anything works is that if you actually send a request to /users, it's a little bit different than /users/. And I'm actually going to show you what happens when we do that. So I'm going to, first of all, open up UVcorn. So I've started out my API. And if we go to create user, here I'm going to users and not users/. Right? I'm not doing /, I'm doing /user. I'm just doing users, which is, wait, where did it go? Is it here? Where did I put the things I just typed? Yeah, here. So what we're doing is we're sending a request to this one, not the one above it, because the other one above it has a / at the end. We don't have that trailing /. So if I create a test user without that trailing /, hit send, take a look at what happens in the logs. It says that when we get a request to /users, we're going to send a 307 redirect to /users/, because technically the route's on /users/, and FastAPI is intelligent enough to actually send the redirect to here. However, this creates an issue with our testing, because if I just do /, what's going to happen is when I do this res.status code check, it's going to check for 307 and not the final 207, the final 201. And I could show that to you guys. So let me go down here. We'll run our test real quick. And you'll see that it fails. And it fails because, well, there's a couple of issues. It fails. It says it fails because our validation for our schema failed. But I'm going to skip that and comment that out. And I'll comment this line out. I just want to take a look at the status code. Because obviously if there's a redirect, there's no information in there. Right? And you can see that this fails because the response code is 307. So that's why you want to make sure you add that trailing / or then you'll run into some issues. So we've got our create user test pretty much done. You can feel free to customize it however you want. If you want to add a few extra assert statements, feel free to do that. But we're going to move on to login. So let's actually handle setting up the login. So I'm going to do def test underscore login underscore user. All right. And this test is going to be dependent on the client fixture because we need to be able to send a request. So I'm going to pass in client. And I'm actually going to copy this line right here. We'll change it, of course, but all right. And so we're going to, this is going to go to /login. And there's no trailing / on this one, just because if you actually look at our specific route for login, I think it's under auth.py. You can see there's no prefix here. It's just /login. So we don't need the trailing / on this one. You just have to figure out how you set yours up and make sure it matches accordingly. We do /login. But in this case, we don't want to send this data in the body. Instead, remember, if you go to Postman and you go to login user, we don't send it in the, well, we do send it in the body, but instead of using the normal JSON format, we have to send it as form data, remember? And so to change this to be form data, you just change JSON to be data. And we've got the same credentials, so this should work. Let's just quickly just do a assert. And what is a login return? A login returns it should just be a 200. So we'll do a 200. Assert res.status code equals 200. All right, and let's test this out now. And it looks like we got an error. So what happened here? Let's take a look. It looks like we got a 422 as our status code. Why would we get a 422? And if we take a look at our logs, we don't really get much information here. So what I'm going to do is we're just going to print res.json so we can see what's going on. All right, why did we get a 422? Is there any other details it's going to provide us? So I'll do a -s so it prints it out. And we can see in the print statement, it says, oh, look at this. There's some sort of validation issue. Detail, lock body username message field required. Type value error missing. So remember the field for the email when you log in is not actually called email. It's called username. So we have to fix that. So it's going to be username. All right. Now let's test this out once more. All right, we get another failure. So let's see. This time we get a 403. Okay, interesting. So what's happening? Why did we get a 403? Let's see. Detail says invalid credentials. Interesting. So if I go back to my login route, right, you could see that we get a 403 if the user doesn't exist, which means we couldn't find a user with that specific email, or if the password that was provided doesn't match what's in the database. So this is one of the issues. It's either the user doesn't exist, or the email doesn't exist, or the password's incorrect. So let's go into pgadmin, and if you left your database config so that you don't drop it at the end, instead you drop it before a test case starts, you should be able to see all of your test data. So I'm going to refresh this. And if I go to users, view, edit data, all rows, right? Well, there's no users. Well, that's interesting, right? Because if I go to my code, during our test create user, we should have created a brand new user. So why can't we log in as this user? Well, that's easy to explain. So if I actually go to my database.py, we have these fixtures. And the fixtures have a specific scope, which means when do they run? And right now, they're using the default function scope. What that means is they're going to run before every single function that's dependent on them. So that means when we run test users, right, we can see that test root client, right? Since we're passing client into test root, we're going to run our fixtures before we run this function. Then before the next test, we're going to run our fixture again. And then before this test, we're going to run our fixture again as well. So why does that actually cause the user to get deleted? Pretty simple. Because we run this test, right? The test create user, the user's in the database, and then we start to run the test login user. And so since we're dependent on the client fixture, we go to the database.py file, we can see that the client calls session. Session, what does session do? Well, it drops the database, or it drops all the tables at least, and then it creates all of the new tables. So we get a brand new database every single test that we run. That's why the user isn't there. And if you want to learn more about scopes, I recommend you go here, and then I think, if I go to API reference, I think, and then fixtures, let's go to examples. and go to fixtures right here. And then here I can search for scope. Here we can see the different scopes. So the default right now is that our scope is functions, which means that the fixture is destroyed at the end of each test and it's run for every single function. We then have a fixture that's set to a scope of class, which means that it'll run once per class and it'll run all the tests in the class. Then we have a fixture module. So when a fixture is set to a module, that means for all of the tests in a specific module, right? Like in this case, all of the tests here, we're going to run the fixture just once at the beginning, and then we're not going to run it again for that module. So all of the tests will have access to just that first instance run, essentially. And then we also have it for package, where it's going to run once per package. And then we also have session, where it's going to run once at the start of the testing session, and it's going to get destroyed.